Hi, everybody. Today we're going to go over test number 2. So if you look at question 1 over here, it says the diagram shows the construction of an equilateral triangle, and we're asked to pick the statement that justifies this construction. So if you take a look at the construction, what's happening, if you look at the construction marks here and you think about when we learn to construct equilateral triangles in class, if you review your notes on that, the way that we construct an equilateral triangle is that we measure the line segment that's given, and we use the measurement of that line segment to create the two other sides that are all the same length as each other. So the way the equilateral triangle construction works is that we're copying a line segment and using it to create the three congruent sides of the triangle. So when we take a look at the answer choices, we want the answer choice that says that all of the sides are equal, because that's what we're doing when we construct an equilateral triangle. We're creating a triangle that has three equal sides by copying a line segment 3 times to make the sides of a triangle. So the answer choices 1 and 2, they're talking about angles. I see the angle symbol there, so I can automatically eliminate them. Although it's true that all the angles of a triangle add up to 180 degrees, and although that it's true that in an equilateral triangle all the angles are equal, that's not what we use to make the construction. The construction works because we take one of the sides and we copy it to make the other two sides, make 3 equal sides, and we make an equilateral triangle. That brings me to answer choice number 3, which says all of the sides are equal to each other, which is exactly what we're doing to make this construction, exactly why the construction works. If we take a look at number 2, it says the measures of the angles of a triangle are represented by 2x, 3x minus 15, and 7x plus 15. And it's asking us to determine what kind of triangle that we have. So we talked about in class that whenever we are approaching a question that mentions a triangle, but we don't see a triangle in front of us, our very first step should be to draw our own triangle. And a lot of people didn't do this on the test. I know 3 of the angle measurements, the expressions that represent them, so I'm going to label them in the triangle. I'll call this one 2x. I'm just randomly putting each one at a different angle because we don't know which one's which. I'll put the 3x minus 15 over here, doesn't matter. And I'll put the 7x plus 15 here. Once again, doesn't matter. Each of the angles in each of the spots. So we know that whenever we have a triangle, all 3 of the angles always add up to 180 degrees. So I'm just going to make an equation that says the red angle plus the blue angle plus the green angle is equal to 180 degrees when you add them all together. Now let's just solve the equation. A lot of you need some practice solving equations. We go over it in class as much as we can, but it is an Algebra 1 topic. Make sure that you do come to tutoring or review the resources on Google Classroom or watch some YouTube videos on solving an equation if that's something that you struggle with. Let's combine the like terms first. So we have 2x, 3x, and 7x. 2x plus 3x is 5x, plus 7x is 12x. So we have 12x minus 15 plus 15 is equal to 180 degrees. Combining the last 2 like terms, negative 15 and positive 15, that's 0. Negative 15 and positive 15 cancel each other out. So we're just left with 12x is equal to 180. Now, all we need to do is solve for x. So what we need to do is take our calculator and put in 180 divided by 12, divide 12 on both sides, and we get x is equal to 15. Now, the question didn't ask us for x. It asked us to determine what kind of triangle this is. So what we need to do is take our x value and plug it in to find out what the angle measurements actually are. So plugging into the red angle first, 2 times 15 is 30 degrees. Plugging into the blue angle, 3 times 15 is 45, minus 15 is 30 degrees. And finally, plugging into the green angle over here, 7 times 15 is 105, plus 15 is 120. So let's look at the answer choices from the bottom up. Answer choice 4 says that we have an equiangular triangle. That means all the angles are equal. Clearly here, all 3 of the angles are not equal to each other. 2 are equal, but the last one isn't. So I'm going to put one out. Answer choice 3 says an acute triangle. That means all of the angles are less than 90 degrees. But wait, we have an angle here that's more than 90 degrees. It's 120 degrees. So we're going to eliminate that choice. A right triangle has an angle that is 90 degrees, but I don't see any 90-degree angles here. So I'm going to cross that off. And our last choice is an isosceles triangle. Remember, isosceles triangles have two equal sides. And whenever we have a triangle that has two equal sides, the angles opposite those sides are also equal. Two equal sides means two equal angles. And wait, we have two equal angles here. So that means two of the sides are equal as well, and this is an isosceles triangle. Moving on to number 3, it says a student used a compass and a straight edge to construct segment CE right over here in the triangle. And we want to know which statement is always true for the construction. Before I even look at the statements, I want to try to figure out what construction is here. I see this first arc, this first construction mark on this angle over here on angle C. And then I see these smaller two arcs of equal length. And I see the construction that we're working with here is the angle bisector construction. And if you're not seeing that, take out your construction packet and look at type 5. Type 5 in your construction packets is angle bisector, and you'll see it looks exactly like what was done over here. If you lost your constructions packet, you can pull it up on Google Classroom under Unit 1 classwork. It is titled Constructions Packet. Now that we know that CE is an angle bisector, we know that it's splitting angle C into two equal or congruent parts. So angle C is being broken down into two smaller, equal, congruent angles. So what we're going to do is look for the answer choice that says that. Answer choice 1 says angle CEA, that's right over here, CEA with E in the middle, is congruent to angle CEB, right over here with E in the middle. But I know that angle C is being bisected. The angle bisector construction is on angle C. So these are not the two equal halves of angle C. These are. So that's not the correct answer choice. So let me eliminate that. Answer choice 2 says angle ACE right over here because C is in the middle. So that's one of the angles that we're talking about that we want, is congruent to angle BCE right over here with C in the middle. That's the other angle that we want. This is the correct answer choice. It's mentioning these two halves of angle C, which we know for sure are equal to each other because we do have the construction of an angle bisector here. Remember, angle bisectors split an angle in half into two equal parts. So you picked answer choice 3. That's saying that AE and BE are equal to each other. Those are the two pieces of side AB of the triangle. We don't know that E is the midpoint of the triangle. We don't know that we have a perpendicular bisector of a line segment. We don't know we have a median of the triangle. So based on just the construction that's shown here, which is an angle bisector, we don't have enough information to conclude for sure that AE and BE are in fact congruent to each other. And if you picked EC as congruent to AC, well, EC is the angle bisector that was constructed, and AC is a side of the triangle. They don't have any relation to each other. So goodbye, answer choice 4. If we take a look at number 4, they tell us that Peach Street and Cherry Street are parallel. So I'm going to draw that into my diagram. Those arrows mean that the lines are parallel to each other, and they tell us that in the question. We're told that Apple Street intersects them, as shown in the diagram below. So I see I have a situation with parallel lines cut by a transversal. So I'm going to go ahead and highlight that. So here are my two parallel lines, and here's the transversal that intersects them. Let's be on the lookout for our angle relationships formed when parallel lines are cut by a transversal. They tell us that angle 1 is 2x plus 36. And they tell us that angle 2 is 7x minus 9. The angle relationship that stands out to me is angle 2 and this angle up here. Those angles are corresponding angles because they're in the same position where the parallel lines meet the transversal. At this intersection point, angle 2 is top right. At this intersection point over here, angle 2 is top right as well. Corresponding angles are in the same position, and as long as the lines are parallel, which they are here, corresponding angles are congruent to each other. So if angle 2 is 7x minus 9, this angle over here is 7x minus 9 as well. Now think about the relationship between this angle in green over here and angle 1. Together, they form a straight angle, which is 180 degrees. They are supplementary to each other. So once I know that angle 1 and the angle next to it have 180 degrees, I can make an equation to find x. I can say that angle 1, which is 2x plus 6, plus the angle right next to it, which is 7x minus 9, add up to 180 degrees. Combining my like terms, which are 2x and 7x, I get 9x. I also need to combine my other two like terms, 36 and minus 9. That's positive 27, and that's equal to 180 degrees. Let me subtract 27 from both sides. So 180 minus 27 is 153. So we have 9x is equal to 153. And finally, let's divide 9 on both sides to get x by itself. And we get x is equal to 17. Now notice that is an answer choice here, but the question did not ask you to find x, so don't be tricked by that. Always make sure that you're answering the question that is being asked of you. There'll always be other answer choices that are there to trick you because they're right, they're what you're supposed to find, but they're not what you're answering as your final answer for that question. Here, the question asks, what is the measurement of angle 1? So what we actually do is take our x value and plug it in for angle 1 and see what angle 1 actually is. So that will be 2 times 17 plus 36. So 2 times 17 is 34, plus 36 is 70. So angle 1 is actually 70 degrees. Moving on over here, we're told in the diagram below, lines N and M are cut by transversals P and Q. What value of X would make lines N and M parallel? Okay, so just like when we have parallel lines cut by a transversal, our angle relationships that we learned about hold. If you want to instead show lines are parallel, all you have to do is find one of the angle relationships that we've talked about in class and show that it's true, and then that makes the lines parallel. So let's find that here. So let me highlight my parallel lines. Well, not my parallel lines, my lines that I want to show are parallel. And so now that I have my lines that I'm showing are parallel highlighted, that's just going to make it a little bit easier for me to see what's going on. The first angle relationship here that jumps out to me is vertical angles. We have this 80-degree angle, which is vertical to this angle over here. Since vertical angles are always congruent, that angle is 80 degrees as well. Lines don't have to be parallel for vertical angles to be congruent. They are always congruent to each other. Now that I know that, I can see that this angle plus this angle plus this angle, all those three angles together make a straight angle, which is 180 degrees. So I already know two of those angles making up the 180 degrees. I know this one's 30 and this one's 80. That's 110. This last one over here is 70 to make all three of them add up to the 180-degree straight angle in total. I highlighted my lines that I'm showing are parallel, but I didn't highlight my transversal. So there's two transversals here. I'm just going to highlight this one first. Because now that we have that 70-degree angle, I want to point out that we have alternate interior angles here. We have two angles that are inside the two yellow lines, but on different sides of the transversal. So the angle that would be alternate interior with the 70-degree angle is this angle right over here. Let me use a different color and let me mention why one more time in case anyone's confused. Both of these angles are within two yellow lines. They're inside the lines. That's the interior part. They're on different sides of the transversal. This one's to the right of the pink transversal. This one's to the left of the pink transversal. That's the alternate part. So they're alternate interior angles. Remember, if alternate interior angles are congruent, then lines are parallel. So if this alternate interior angle was 70 degrees, then we would know that we had a pair of congruent alternate interior angles show that the lines are parallel to each other. So once again, if I can show that a pair of alternate interior angles are congruent to each other, that's enough to prove that we have parallel lines. So if x is 70 degrees, if it's the same as this angle over here, then we would have a congruent pair of alternate interior angles, making the lines parallel to each other. For number 6, it says given triangle ABC with base AFEDC, median BF, altitude BD, and BE bisects angle ABC, which conclusion is valid? So let's take a look. So we have median BF. So if BF is the median, then I know F is the midpoint because median connects vertex to opposite midpoint. So F would be the midpoint of side AC of the triangle, which means that from A to midpoint F would be congruent to from F, which is the midpoint, to the other endpoint C. So those two pieces would be congruent. And already I see that answer choice over here, CF is congruent to FA. So I already found a conclusion that's valid. But let's talk about why the other ones are not valid. So they also tell us that we have altitude BD. So altitude is a perpendicular line, forms a right angle. They already have that for us in the diagram. So there's no other conclusions we really need to draw there. And they also tell us that BE bisects angle ABC. So I know that angle ABC, which is this angle over here, ABC with B in the middle, that's this whole angle up here, is being cut in half by BE. So from this end of the angle to BE is congruent to from BE to the other end of the angle. So if I take a look at answer choice 1, it says angle FAB, so that's all the way over here, is congruent to ABF, which is up here. I don't know anything about the relationship between these two angles, so that's not the right answer choice. Nothing in the givens lets me know anything about the relationship between these two angles. Answer choice 2 says angle ABF, that's right over here, is congruent to angle CBD. Well, I don't know that. I knew that I have an angle bisector, but BE is the angle bisector. So from here to BE is the same as from BE to the other end of the angle. I don't know if these two parts of the angle are congruent. I have no idea. Don't know anything about those relationships. So I'm going to cross out that answer choice. We have no reason to believe that those two angle parts are congruent to each other. Let me get rid of that. There we go. And finally, CE is congruent to EA. So CE is over here and EA is over here. Well, we didn't base things on the diagram, but clearly the green part is shorter than the red part. Also, F is the midpoint. We knew that because BF is the median, so it connects to the midpoint. So F's the midpoint, so that's the middle point. So this is not equal halves over here because F is the midpoint. So from F to C would be an equal half, and from F to A would be an equal half. This is not an equal setup here. Okay? That brings us to answer choice 4. CF is congruent to FA from midpoint to endpoint, from midpoint to endpoint are congruent to each other. Okay, let's move it forward. So this one, we have a bunch of different information. I'm not going to read the whole question because you guys took the test, but it's asking us to find this angle over here. So we learned in class the exterior angle theorem for triangles. And what that says is that an exterior angle of the triangle is equal to the sum of the two inside angles that are not right next to it. So here's our exterior angle. This angle is not right next to it, and this angle is not right next to it. So those are the two that we're going to add together to figure out what the exterior angle is. So I'm just going to make an equation that says the exterior angle, which is x plus 20, is equal to the sum of the two angles not right next to it. So x plus 40 plus 4x minus 5. All I have to do is combine my like terms and solve for x. Here we have, that's 5x, 40, and minus 5, that's 35. That's equal to 6x plus 20. We didn't do anything there yet. Okay, I'm going to subtract 5x from both sides. So I'm left here with x plus 20 is equal to 35. And then I'm just going to add 20 to both sides, and I get x is equal to 55. Remember, the question didn't ask for x. It actually asked for what the measurement of angle QPT, the exterior angle, is. So using my calculator, I'm just going to plug our x value in. So I have 6 times 55. That's 300. Oops. 6 times 55. Oh, my bad here, guys. In my solving, I said we're going to add 20 to both sides, but we should be subtracting 20 from both sides because it's positive, and we need to use our inverse operations to solve the equation. So my bad, guys. X is 15. So 15 is the x value that we're plugging into angle QPT. So let me do 6 times 15 is 90, plus 20 is 120. And there we have the measurement of angle QPT. Okay, for this question over here, there was an error that was found in period 7. So if you were before period 7, you didn't make the correction on your paper, but that is okay, because as long as you had the correct setup or were on the right track, you did get credit for that part of the question that had the error. The only way you didn't get credit for that part of the question was if you didn't make any attempt, or if your setup was like completely off and wouldn't have led to the correct answer anyway. So let's take a look here. So let me first make the correction. The correction is that this, in AP, this was supposed to be a y instead of an x, and that's the only correction. So in triangle WHA, WP is both a median and an angle bisector. So I'm going to stop right here. A median connects vertex to midpoint. So P is the midpoint of this side of the triangle, which means it's being split into 2 equal parts. I also know that WP is an angle bisector. So that means WP is an angle bisector, so it's bisecting angle W, which means splitting it into 2 equal parts. That's all going to be important information. Now I'm going to label the measurements of the triangle on my actual triangle here. So AP is 3y plus 11, and PH is 7y minus 5, and angle HWP, so HWP, let me do that in green actually. HWP, that's this angle right over here, is x plus 12. Oh, wait, that means this angle is x plus 12 because they're equal to each other. We have an angle bisector. And they also tell us that angle PAW, so PAW, that's over here, is 3x minus 2. And that HWA, angle HWA, so HWA, that's this whole entire angle, is 4x minus 16. So first let's find y, and then we'll find x. So let me do y in red. So I'm going to write here that we're finding y. So we can just set up an equation that says 7y minus 5 is equal to 3y plus 11. Once again, that's because we knew WP was a median. P is the midpoint, 2 equal parts. Subtracting 3y on both sides, 4y minus 5 is equal to 11. Adding 5 to both sides, 4y is equal to 16. Dividing by 4 on both sides, y is equal to 4. So already we have our y value. Okay, let me find my x value over here. So I know that the angles use x, and I know the 2 parts of angle W are x plus 12, and I know the whole thing is 4x minus 16. I'm going to just set up an equation that says the 2 parts of angle W added together, so x plus 12 plus x plus 12. If we add the 2 parts of angle W together, we get the whole entire angle W, which is 4x minus 16. Combining my like terms, we have 2x plus 24 is equal to 4x minus 16. I'm going to subtract 2x on both sides, so that's 24 is equal to 2x minus 16. And finally, I'm going to add 16 to both sides. That is 2x is equal to 40. And finally, dividing by 2 on both sides, we have x is equal to 20. So already we found x and y. The only last part of the question is WP also an altitude, and we should explain it in words. Remember, an altitude's a perpendicular line. That means it forms a 90-degree angle. So what we need to do now is we actually need to take our x value, since the angles here have x's in them. We have to plug in, and we have to see if there is a 90-degree angle. So if WP is an altitude, the 90-degree angles would be over here, just so everybody knows what we are looking for. So let's figure it out and see if there actually are 90-degree angles here. So I know that this angle W is 4x minus 16, and my x value is 20. So if I plug in 20 there, that's 20 times 4, which is 80, minus 16 is 64. So I know that this entire angle here is 64 degrees. I know that angle A is 3x minus 2. So if I plug in 20 there, that's 20 times 3 is 60, minus 2, that's 58 degrees. And I know that all three angles of a triangle always add up to 180 degrees. Since I know what angle W is and what angle A is, I can find what angle H is. That would be 58 plus 64, and that's 122. And I'm going to subtract that from 180, and that makes this 58 degrees as well over here. Now remember, I'm interested in if this angle and this angle is a 90-degree angle. So I'm just going to focus in on the smaller triangle up here. So in this smaller triangle, I know that this top angle is 58 degrees. I can find this angle over here because I know x is 20. So I can plug it in. 20 plus 12 is 32 degrees. And then now that I have two angles of the triangle, I can figure out what the last angle is, and I can see if it is 90 degrees. 58 plus 32 is 90 degrees, so that means this is 90 degrees as well. And there we have it. WP is an altitude. You can explain that in words. You should explain that in words. Why is it an altitude? What did we just talk about? Okay. Let's move it forward. It says here, using a compass and a straight edge, construct an equilateral triangle with AB as its side. Let me just make this A and B. Okay. Using this triangle, construct a 30-degree angle with its vertex at A. First, I'm going to handle the first part of the question, which is to construct an equilateral triangle. So I'm just going to measure the length of this line segment. This is going to be the measurement of all the sides of the triangle, since they should have 3 equal sides. So with my compass, I'm just going to measure from A to B. And then all I'm going to do, my endpoint is still at A. I didn't change the radius on my compass. If you're using a flat one, I didn't change the hole that I'm using. I'm just going to make a small arc over here. And then I'm going to turn my compass around, and I'm going to pick it up and move it over to point B using the same hole or the same radius. I'm simply going to just make another arc. And that's it. Now I should be able to draw a triangle that has 3 equal sides. I'm just going to connect up to the intersection of the arcs. Oh no, I'm very bad at connecting lines. Let me try that one more time. Let me draw my line again. So I'm going to connect from A up to the intersection point of the arcs and down to B. And look at that. I have 3 equal sides of my triangle. So I have an equilateral triangle, and all the sides are the same length as AB. So we did part A. We constructed our equilateral triangle. So all we have to do now is part B, which is constructing a 30-degree angle. Remember, if all the sides are equal in a triangle, all the angles are equal. So if all the angles in a triangle add up to 180 degrees and we have 3 equal angles, that means each one's 60. 60 plus 60 60 is 180. In order to get 30 from a 60-degree angle, you just have to cut it in half. And that's our angle bisector construction. So you can bisect angle A because it says the 30-degree angle should have a vertex at A. So I'm just going to pick up my compass and put it over to point A. That is the angle that I am bisecting. And all I'm going to do is just make a small arc. It doesn't matter how big. It just matters that it hits the angle in two spots. I'm going to pick up my compass and I am going to make an arc at this top intersection point on the left. Then I'm going to pick up my compass and move it to the other point where the arc hits the angle. And I'm going to make the same exact arc using the same hole or the same radius on my compass. Finally, through that point where the arcs intersect, starting at vertex A, I'm going to draw my bisector. And there we have it. We have split angle A into two equal parts, changing it from a 60-degree angle to 30-degree angles. And there we have it. Okay, let's check out number 10. So number 10 is asking us to find the measurement of angle CHF. In order to do that, I'm just going to highlight my two parallel lines. And I'm also going to highlight the transversal for you guys. Let me try to do that a bit thinner. So here are my two parallel lines. In the question, they tell us that AB and CD are parallel to each other. A good idea is to also mark it in the diagram. I'll do that here for you guys so you can clearly see it. It does say parallel lines AB and CD. And we do have a transversal GH. So I'm just going to highlight that. It tells us that that's the transversal in the question. Let me get my highlighter out. My computer is very freezy right now. Okay, let me highlight that transversal. I'm a bad highlighter. There we go. So now we can think about what the relationship is between the two angles that they give us information about, the angle labeled x plus 15 and the angle labeled 2x. Notice how both of the angles are within the two parallel lines. They are inside the line, so we call those interior angles. And notice how they're also on different sides of the transversal. This angle's to the left of the transversal, this angle's to the right. So these are alternate interior angles, and we know alternate interior angles are congruent to each other when the lines are parallel. So all we need to do is set up an equation that says the two angles, so one of them is x plus 15, or that'll make it quicker. X plus 15 is equal to 2x. All I have to do is solve for x, so I'm going to subtract x from both sides, and I get 15 is equal to x. So now they're asking for the measurement of angle CHF. CHF is right over here. Notice how CHF is a vertical angle to the 2x one. So if I know what the 2x angle is, I know what the angle vertical to it is because vertical angles are always congruent. 15 times 2 is 30 degrees, making this one 30 degrees as well. Okay, we're going to write the equation of a line that passes through the point 4, negative 1. And is parallel to the line with the equation. So in order to write the equation of any line, we need two things. We need a point and we need a slope. It's the point here in the question. It's the point 4, negative 1. We just need to find the slope. So what we're going to do first is solve the equation that makes us y. That way I can clearly see what the slope is. So I'm going to add both sides. And then I'm going to divide each term by 2. And each side by 2 is 4. Now, I have x over 2 here, but remember, whenever you have an x without a coefficient, there's an invisible 1 in the front. So I can actually write that. Oops. I divided by 2 already. Let's get rid of that. I'm messing everything up here. There we go. Okay, so we're dividing everything by 2. And remember, there's an invisible 1 in front of the x. So I can actually rewrite that term as 1 over 2x, just pulling out the numerator and denominator and writing the x next to it. That way I can clearly see what my slope is. Remember, our slope is what's attached to the x when we have an equation that's solved for y. So our slope half. And now we're all ready to write the equation of our line. Parallel lines have same slopes, so this is going to be the slope of our parallel line as well, same as the original. Remember, point slope form is y minus y1 equals m minus x1. This is the format of the equation of a line. All we need to do is plug the slope in for m, the x coordinate of our point in for x1, and the y coordinate of our point for y1. The y coordinate of the point we're using is -1. Our slope we just found is 1/2. And the x coordinate of the point that we're using is 4. And that's it. You don't have to solve for y. You can stop right here. If you solve for y, you might make a calculation error, so that's it. It's a perfectly valid and correct equation of the line. In the next question, we have to write an equation of the perpendicular bisector of the line segment whose endpoints are -1, 1 and 7, -5. So remember, anytime we write the equation of a line, we need a point and we need a slope. Since we are dealing with a bisector, bisectors cut line segments in half, so they always pass through the midpoint of the line segment, which is the halfway point. So I'm going to need to find the midpoint. So let me use the points here to find the midpoint. Remember, midpoint formula is the average of the x's, comma, the average of y's. So I'm just going to plug in. Our x coordinates are -1 and 7. Our y coordinates are 1 and -5. -1 plus 7 is -6. Divided by 2 is -3. 1 plus -5 is -4. Divided by 2 is -2. So, oops. +6 divided by 2 is +3. There we go. Like that. Make sure we have our signs correct after our adding and our subtracting. Here we're adding and dividing. There we go. So we have our midpoint, which is the point that we're going to be using. All we need next is the slope. So let's find the slope of the line segment here. Slope formula is y2 minus y1 over x2 minus x1. So our y coordinates are -5 and 1. So I'm going to subtract them, -5 minus 1. And our x coordinates are 7 and -1. So I'm going to subtract them. And what do we get here? We get -6 over 8. So we can reduce that if we want. That reduces to -3 over 4, but there's really no need to. I'm just going to leave it as is. So remember, we are writing the equation of a perpendicular bisector, and perpendicular lines have negative reciprocal slopes. So in order to get the slope of the line perpendicular to this one, all I'm going to do is take the negative reciprocal of the slope here. I'm going to flip it and change the sign. So in the fraction, I get 8 over 6, and I'm going to change the sign from negative to positive, and that's the slope that we're using. Now we have our point and we have our slope. All we need to do is plug into point slope form to write the equation of our line, just like we did in the previous example. So our y coordinate of the point that we're using is -2. Our slope is 8 over 6. And our x coordinate is +3. And there we go. You don't even have to solve for y. All done.